Okay, so here's a little solution. It'll help you out a little bit. So what we have is we have these three forces acting on this one point. So we have T3, T1, T2. That was just me deciding. And we said we had angles of 25 degrees. And then we had the next angle, which goes from the positive x-axis to T2, and that was 180 minus 40, which was 140. And then we had the third angle, which goes from the positive x-axis all the way around to here, and that's 270 degrees. And what happens is all these three force vectors have to add up to a zero force vector, or all the components have to add up to 0. The x components have to add up to 0, and the y components have to add up to 0. And what we said was that T1x was equal to T1 cosine of 25 degrees, because that's the horizontal. T1y is equal to T1 sine of 25 degrees. T2x is equal to T2 times the cosine of 140 degrees. T2y is equal to T2 times the sine of 140 degrees. And then we have T3x, which is equal to 0. And T3y is equal to T3 times the sine of 270 degrees. So if we add up all the x components, they have to add to 0 because it's an equilibrium problem. So we have T1x plus T2x plus T3x, and in the y direction we have the sum of the forces in the y direction equals 0, which is T1y plus T2y plus T3y. Okay, so if we plug all these expressions in, T1x is T1 cosine of 25 degrees, T2x is T2 cosine of 140 degrees, and T3x, which is 0. And if we do that in the y direction, we'll get T1 sine of 25 degrees plus T2 cosine of 140 degrees plus T3 times the, I did that again, sine of 140, T3 sine of 270 degrees. So we've got two equations and two unknowns. We do know T3, and it's going to take on two values. So we could, let's do over here, T3 is equal to the weight, which is equal to the mass times acceleration due to gravity. So for the first option, we've got 7 kilograms for the mass times 9.8 meters per second squared. And for the second iteration, we've got 18 kilograms. Okay, 7 times 9.8, 68.6 newtons. 18 times 9.8, 176 newtons. So those are T3. So we can then come up with these two equations. 0 is equal to T1 cosine of 25 degrees, which is cosine of 25.906. plus T2 times the cosine of 140, which is a negative 0.766 plus 0. And then the second equation is T1 times the sine of 25, which is 0.426 plus T2 times the sine of 140, which is 0.643. And then we have minus 176 newtons. That's this number, and the sine of 270 is negative 1. For the second group, well, actually this applies for all the groups. Well, no, it doesn't. The only difference between the first and second problem is this number here. And so actually I used the wrong one there. I should have used 68. 68.6. And then we have the second one, which has the same x equation. I'm going to go ahead and get this negative sign out in front. Negative 0.766 T2. And then we've got 0.426 T1 plus 0.643 T2 minus 176. So then you could solve these. You could solve this one for T1 is equal to something, and then you could substitute it in and solve for T2 here, and you do the same over here. Now what I'm going to do is actually I'm going to do this all algebraically, and you can do them this way, and I'll do it this way, the algebraic way, and that way we can make sure we did it right. Okay, so what I would do if I solve this thing algebraically, I'd solve this one for T1. So it's going to be negative, so I'll move this to the other side, it'll be negative T2 cosine of 140 over the cosine of 25. And then I'll substitute that in here. Actually, I'll substitute it in over here. So if I do that, I'll get 0 is equal to T1, except that's T1 is, so just write that down, negative T2 cosine of 140 over cosine of 25. So that's what T1 is equal to. And then I multiply by the sine of 25. And then I got the second part of the equation, which is plus 0.643 T2 minus, so this number here is the weight. So I'm just going to put it in as W. I'm going to make this just a function of W, because that's the thing that changes. Okay, so if we factor out a T2, we'll get T2, and I'm going to move this to the front, 0.643. Actually, I should have just left it as the sine of, what did I do here? I'm using this one, I should have gone up here. So that one, I did the first part right. I should have used the sine of 140 here just to keep it in terms of sines and cosines. Okay, sine of 140. Okay, so instead of doing that, I'll put in the sine of 140 minus cosine of 140 over cosine of 25 times the sine of 25. And then I'll add w to both sides to solve for that. And so ultimately I get T2 is equal to w divided by this expression, sine of 140 minus cosine of 140 over cosine of 25 times the sine of 25. And, you know, I could have been even more general. I could put in these angles, but let's not get too carried away here. Okay, so T2. So this is for W equals 68.6. And I can check this later so we'll know if it's right or not. So we get 68.6 divided by, and you'll notice actually this whole thing in the denominator doesn't change. So let's just calculate that and just put it in. So we have the sine of 140 minus the cosine of 140 divided by the cosine 25 times the sine of 25. That doesn't seem right. What did I do wrong? What I'm getting is 1, and I know that's not correct. So let me pause for just a second. Okay, well, I guess it does actually do that. So this actually is 1. So it's interesting. There's got to be some trig identity reason why this is the case, because it wouldn't normally happen this way. Anyway, we got T2 is 68.6 newtons, and then T1 would be negative T2 cosine of 140 over cosine of 25. So if you do that, and you substitute that in, so we take negative 68.6 times the cosine of 140 over 25. You'll get 58.0. So that's T1, and the reason I know it works is because if I take T2 times the sine of 40 degrees, instead of using 140, if you use 40, and I add that to T1 times the sine of 20 degrees, 25 degrees, I'll get whatever that number was, 68.6, which balances the weight. So apparently it does work. And so now that I know that, the second one, T2, is going to be equal to just W, which was 176 newtons. And then T1 is equal to 176 times the cosine of 140 divided by the cosine of 25. So I get 149 newtons. So that's the second case, and this is the first case.